Hello, my name is Kang, and today I will talk about cross-site request forgery, one of the common attacks on websites. Cross-site request forgery is an attack that forces users to submit a request to web application which they are currently authenticated with using their session IDs. Cross-site request forgeries attacks exploit the trust of a web application as in an authenticated user by targeting its inability to differentiate between a request generated by an individual user and a request generated by a user without their consent. For this demonstration, we have built a banking website that contains features such as account registration, login, and funds transfer. I have already set up a few accounts with their own respective balances. As you can see, the first account I logged into, named Chica, contains a large sum of balance in their account. They can freely log out and back in, select people to transfer their funds to. But let's say that a malicious user knows we're currently logged in and is in a session within the banking website. They also know that there is a vulnerability in the funds transferring system of the website, where it uses the GET method for the requests instead. Then they attempt to get us, the user, to somehow access one of their links. This can be done in a variety of ways by including a malicious link that directs the user to a page that uses the GET method and is manipulated with custom queries or variables. In this case, we will be contacted by Sarah via email, and once we have opened her message to read it, when we return, we find out that funds have been involuntarily extracted from our balance. And since Chica is already logged in, the request is executed under their session, unknowingly transferring funds. So just by opening an email, Chica has lost money without clicking anything. How is this possible? We can start by looking at the link used to deceive us. As we can see, the link is hidden within an image element, which loads the source website to access the image on there to display, and it so happens to lead us to the transaction processing page, causing us to inadvertently send a request to the server without our knowledge. The most prominent way to combat this is to implement CSRF tokens across all of our web forms. It ensures that all requests are made by the right user in question by generating a secret token that only the user's session contains and inserted into every form as a verification. So when the user logs in, the server generates a unique token that is stored in their session. Every form on the site is also modified to discreetly include this hidden token for comparison later during the processing, ensuring the request originates from the real user. If the token is missing or incorrect, the action is blocked. This makes sure that only legitimate requests can be processed, protecting users from CSRF attacks. Overall, cross-site request forgeries are stealthy and dangerous attacks that can steal money, modify settings, or even change user emails. But by using CSRF tokens, we can ensure that only legitimate actions take place.
Hi, my name is Khoa, and now I will discuss about SQL injection attack. This is a security vulnerability that occurs when an attack manipulates a web application database queries by injecting malicious SQL code into user input field. These injected queries can be used to retrieve, to modify, or delete sensitive data. So to better understand this vulnerability, I have prepared a demo with two versions of the code. One is vulnerable and one is secure. So by comparing them, we can identify the weaknesses in secure web applications and understand how to prevent such attack. So let's begin by looking at the banking website that requires user to enter the username and password to log in. Since this is just a demonstrations project, so we have decided with two buttons. The first one is secure, blue one. The red one is vulnerable, the red one. Okay, so this setup will allow us to easily compare how secure and how insecure implementations behave differently. So first, let's look at the database here. Okay, So right now there's no account. I don't have any account named Qua right here. So I will create one. Qua 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. So we also have two buttons here, and I already put the blue one is secure and the red one is vulnerable. Okay, so I will register with the secure button first, and my account is created properly. Now I will try the second button. Create an account name Ken 1, 2, 3, 1, 2, 3, and 1, 2, 3, 4. So it's appear to create the account normally here. Okay, but the underlying security risk is huge. As a hacker, I can easily determine if this firm is vulnerable or not. As an attacker, I will entering this following command to the username field in the bank registration. Single code, union select, one double dash, double space. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. I will first hit the secure button, and it won't accept this kind of username with this error message. But if I use the vulnerable register button, it will let me another error message with this message. So this error message revives the structures of the database, which help the hacker guess the number of columns. So let's try with the login sections. I will type Qua 1, 2, 3, and I will hit login, and it sends me directly to the transactions page. If I try with the login vulnerable here, and it also sent me to the transaction page, but the difference is here. So let's talk a little bit about this code. This single code is important in SQL because it defines string. Attacker exploit it to manipulate the query structures. The OR space 1 equal 1 condition is always evaluate to true, meaning the queries will match all record in the database. The double dash here is used to comment out the rest of the SQL statement, prevent syntax errors, and bypassing authentications check. So now I will hit the vulnerable. No, I will hit the secure first, and it's say invalid user. Okay, but if I hit the login vulnerable, so now you can see that I am logged in without needing any real username or any password. Okay, now let's analyze the code to understand why one version is vulnerable and the other is secure. First, we'll look at the vulnerable login code line number 11 and 12. I already marked here. So this directly insert user input into the SQL queries, and it allows attacker to manipulate the queries using the code line single code space OR space 1 equal 1 space double dash and double space. Okay, let's look at the secure login code. So we look at line 14, 15, and 16. This is the difference. It's used the repair statement to prevent the SQL instructions, and it ensures input is read as a string, not executable SQL code. So by conclusions, SQL injection is one of the most common and dangerous web security vulnerabilities. So the vulnerable code allow attacker to bypass authentications, steal data, or modifying database. And the secure code use prepare statement, input validations, and CSRF protections to prevent the attack. So by following the best security practice, developer can protect web application from SQL injections and other security tips. Thank you for listening.
Hi, my name is Ethan, and I am going to talk about the XSS attack and prevention method. XSS stand for cross-site scripting is a serious security vulnerability that allows attacker to inject malicious script into web applications, leading to data theft, session hijacking, and website defacement. This presentation explains how this SS attack work and demonstrate effective mit mitigation strategies using a PSP-based bank account system. Consequences still the hacker can steal the cookies, get sensitive information like name, email, or password, redirect victim to this phishing site, record keystrokes to steal information. But we talk about how XSS attack work. Consider the following insecure PSP code that sent here without any security method. It's easy for XSS attack because the script retrieves user input, name, password directly from dollar bolt array. The input is inserted into the SQL query. Here, the ID username and password will insert to the database. And when display, if an attacker submits a malicious script, such as script tag alert, something like XSS attack, it will be stored in the database. When displayed on the web page, the script executes in the user's browser, leading to an XSS attack. There are some prevention methods. We should implement multiple layers of security. Method number one is the input validation. Here, input validation is restricting input to only accessible characters, prevent the injection of malicious script like this. The red mark function ensure the name field contains only letters, numbers, and space. The checks prevent attackers from injecting script into the database. Method number two is output encoding. Here, you can see we use HTML special char and we use it to convert special character like some special like greater or smaller into harmless HTML and sometimes ensure that any store script do not execute in the browser when displayed. We will use an example for this so-called about the demo XS attack. Remember to open the same control panel, and then we will go to web page. First, we create a new account. We set up an account. Here, you can enter name and password. Register here. Resistance the best login name. And you will see in the database here. I will login. Login. Yeah. Here's transfer fund. receive something and log out. I will create a demo XSS attack. The alert and password can copy and paste to quickly anything. This is and this is successful, and we will go to the database to see clearly here. Okay, and we will log in again, and we will see the result. Yeah, the alarm executed, and we move to another user browser. You can also see this appear in their browser. I will present. Yes, appear that. Yeah.